Wait. Okay, now what we also have on the test is a multiple choice section. Gave you this today. If you don't have it, it's going to be on the website, so download it. What we have here, number 1, styrofoam is an insulator. Number 2, heat travels from the sun to the earth by radiation. Number 3, energy is transferred by convection. This is a little bit confusing for kids because they think liquids or they think gases, but both liquids and gases are called fluids. So the right answer to a convection current is a convection, or is a fluid. So convection happens with fluids. That's the right answer. Evaporation. It takes place when a liquid goes to a gas. Now, the whole basis of the next couple of questions is this idea right here, that evaporation is a cooling process, so condensation must be a warming process. I think yesterday we all understood that if our skin has some sweat on it and it evaporates, how did it get enough energy for that liquid to evaporate? Well, it got the energy from us. And so if it got the energy from us, it actually subtracted heat energy from us and it cooled us. So going from liquid to gas cools the environment, cools things around it. And so if that is the case, then going from frozen or going from solid to liquid would be cooling as well. Going from liquid to gas would be cooling. So all this direction is cooling because you have to take energy from something. You have to take energy from the environment to melt a solid for it to become liquid. You have to take energy from the environment to take a liquid to become gas. So a pig rolls in the mud to evaporate. It wants the water to evaporate off of its the mud for it to cool. When water freezes, when water's freezing, it's going from a lot of motion to no motion. And so that all that motion goes back into the environment, so it warms it. So if you go from gas to liquid, or if you go from liquid to solid, you heat the environment. So when water freezes, it gives off energy. This is a concept question that we talked about earlier in the week, that steam would burn more than water, even if they're both at 100 degrees. Steam has more energy. If you recall, that's what we talked about. That's how we cook our chicken. When snow forms in a cloud, okay, so we're taking vapor, we're turning it into snow, so it warms it. It is actually sending out some energy. It's slowing it down and sending it out. When water vapor condenses on a window, it warms the environment. We see that with our tea in the summer. If we have a hot or a cold glass of tea with ice and all that, we can see all the condensation forming on the tea. We know that our tea is getting warmer because the energy from the vapor to the water is going into the tea. Melting snow. Melting snow, you can see even I had a hard time wrapping my brain around this. Melting snow will actually cool the environment. And then the lowest temperature possible is 273 degrees centigrade. The back side of the review is right here. All right, so we know that kinetic energy is the same as temperature. All of these are temperature scales except for joule. That makes no sense. Energy and heat is always transferred from high energy to low energy. And again, here's the same question again. High temperature is the same as saying high kinetic energy. This graph we have seen in class. And we know that this graph, the entire time it's gaining heat energy. So the entire time it's gaining energy, but not the entire time is it gaining temperature. That was the whole idea of the graph. So the graph is gaining heat continuously, but only gaining temperature when it's one substance. If it's changing phases, it is not gaining temperature. So that's A. And at what point is the substance undergoing a phase change? The two phase changes are B and D. And it's because they're flat, because the only option they give me is B. The answer is B. So that is the multiple choice part of the review.